So we got 37 means 36 in. Should we start? Today I am going to take two lectures. A Palsar's lecture also I am taking, and he will be taking this lecture tomorrow. Tomorrow, what you have got, first lecture that will be taken by Palsar. Got it?
Okay, sir.
Yeah, just adjustment because he is getting four lectures on a day. It's a little tiring. So we exchanged it. And that this is how it will remain till we get new timetable. Hmm? Ah, so now we are 37. Okay. Yeah, okay, no problem, George. Go ahead. Hmm. So let us start. Anything is left here? No. No. Okay. Now this chapter is sounding and air pipes along with ventilators. Okay. Now let's get back to our basic understanding. What is a tank? It is a type of box. It may not have regular shape like boxes we always get, but it is a type of a box. And what do you put inside tanks? Liquid. Correct? Are we okay up to here? Yes, sir. No, sir. What is it?
Yes, sir.
Okay. So now this box happens to be opaque. I cannot see inside. So that is one of the issues I have. What? I cannot see inside. What is supposed to be inside? Some sort of a liquid when we put it. Otherwise, it may be empty. Now, if I'm keeping it intentionally empty, and suppose there is a crack in ship side or something, and water comes in, how will I know? I will not know anything at sea. So I need to know when it is empty, it remains empty. When it is full, it's supposed to remain full. So I have a question in my mind like, how do I know what is inside? So a box filled up, and I have got no way of knowing what is inside. Now, most of you must have seen in your cars, okay? In your cars, there is an engine. Now, I don't think anybody has got electric car yet. Huh? So I'm using the our standard cars right now for comparison. Now, what happens if you go to even petrol pump and all, अरे oil check करो. So what does that guy do? He puts his hand inside the bonnet somewhere. He finds a long rod like this. He takes it out. He first cleans it. Then again he puts it back. And second time he picks it up. And that time on the bottom part there will be a oil sticking to the this gauge or this wire or whatever you call it, a rod. Okay, it's a flat thing, so you can't call it a rod exactly, but it's like a strip of metal. So you see marking of the oil, right or wrong?
Yes, sir. Right.
Right.
Some of
Yes,
you
sir.
some of you have done it.
Yes, sir.
Yeah, so now you have got
Uh,
idea. What were you doing? You were checking it out, and then there are two markings on it, minimum, maximum, and you expect oil level to be somewhere in the middle. And recommendation is before you start the car, you check it. So that is okay. What we are interested in, you found out the level of oil inside the engine. Same thing. Exactly the same thing we need to do here in on a tank. Okay, tank is huge. So we need to put something inside to find out. Or take another example. If you go in kitchen, okay, you got lots of smaller ones, what do you say, containers, which are see through. You can see how much dal is inside. That is what you will judge the level of this, how much is there. And then generally a person who works in kitchen has got idea how long will it last, so replenishments everything is done. So what is it there, also you are judging the level, but there you can see. Now you also have you also have, say, stainless steel containers filled up with something, rice, dal, atta, whatever it is. So the stainless steel containers, we can open it. Now what we see inside, that material inside is at some level, but how much it is, one is I have to push something inside and see how much it is. Okay, I got this much of atta or say rice. This is sounding. I am measuring the depth of whatever is inside is sounding. And then ships have got calculations, so that if I know the liquid depth is say 2 meters, I open up a table, or in on modern ships you have got a computer doing it, so you just feed it there how much was the depth, 2 meters. It tells you how many cubic meters it is. It's always in cubic meters. And then to make your job easier, another column is added up, salt water density 1025, so the weight is so much. But you always measure is volume. Soundings give you volume, or soundings give you presence of water or dryness. Now we come back to our this reading. Now ballast tanks, we need to fill up water when we are going on ballast passage. Now I don't know how much water is going in. So I have got one pipe inserted in the tank which can be closed from top, and I put something inside just the way we saw in a car. You have got already something put there. So you just lifted it up, checked it. In this case, I have got a portable thing which I bring it. It's a tape with something heavy at the bottom. I put that tape inside, that is a metallic tape, and I take it out and see where water is sticking. That is sounding. Now, with that sounding, I know how much tank is filled up and how much more time will it take, because you cannot overflow water. Overflow means it will just go all over. We don't do that because ports have got strict regulations. They don't like this salt water coming on their berths because there are electrical installations and all. So we don't overflow. So the pipe which is fixed up. Now this is the diagram, okay, of a cross section, not cross section, I will say longitudinal section. Means I am looking at it from side. Now what happens is, mm, okay, okay. Now what happens is, see, here is the pipe, okay. This is the pipe which is open at the bottom. This is open at the bottom so that liquid can flow in and out of this pipe and maintain at same level. That means if my water level is here, the water will fill up and find its own level and it will be here. So if I lower something from here, a tape which goes right to the bottom, then when I take it out, I see this level. So I know by measuring it how many cubic meters are there in the tank. Now every tank will have a different volume, so the respective figures will change. That means 2 meters in a 4P is not 2 meters in double bottom. Tank sizes are depending, and you take that individual tank and you put the thing there and say that okay, how much volume is there. Now I am filling up this tank. So I check it at 8 o'clock, I check it at 9 o'clock, then I see here, then I calculate and say, okay, by 10:30 it should reach somewhere here. Okay. So I monitor it, how fast the water is coming in and so on. Now, we have got many tanks on ship. We have got freshwater tank, we have got ballast tanks, we have got lube oil tanks, we have got fuel oil tanks, diesel oil tanks. So every tank we need to know what is inside. So we are looking at a big tank here where you use the sounding tape, which we will cover up. Sounding tape, all we do is we open the lid here, lower the tape inside till it touches the bottom. Now it is heavy in hand. Once it touches the bottom, suddenly the weight drops down in hand. So I know it has reached bottom. Earlier days we used to use a metal rod tied up with a rope. Nowadays you will not find anybody using that. You will have a tape. And then what we used to do is we used to tap it. If it is water inside, ballast water, the tapping you will not hear, only your hand will feel. If it is supposed to be empty, I mean designed to be empty, like bilge wells, they're supposed to be dry all the time. Coffer dams are dry all the time. So there generally you can even hear tick tick. And we take it out, we see is there any water sticking or any liquid is sticking and so on. Then there are certain more things like water finding paste and all. There are a couple of more things which are used. So this is sounding pipe. Purpose to know how much volume is inside the tank. Clear? Up to this point, are we clear?
Yes, sir.
Okay.
Yes, sir.
Okay. Remember always, sounding pipe goes all the way to the bottom and it is just terminated probably 1 or 2 centimeters above the base. Okay. Now what happens is, we will come back to this diagram again. We will be coming back to this diagram anyway. Okay. So the sounding pipe we are clear. Now sounding pipes are always closed. There has to be a proper arrangement to close it because you don't want in rough weather when water is coming on deck to go in. So it is well closed. Plus there are some additional requirement why it is closed. Now when we go to machinery space, they also have got lots of small tanks built in there. So there you have got fuel oil inside. So it is always risky that if you leave it open, some fuel oil vapor will escape through sounding pipe because you left the cap open. Cap is the top. You left it open by accident. So you don't want. You want to open it exactly the time you actually want to measure that sounding. So what is done? We will go through the diagram afterwards. We have got two arrangement. One is the usual cap on top and then there is a spring loaded arrangement which always remains shut. It remains shut. So you need to open it temporarily. So that's why there is a spring loaded arrangement. So generally you use your foot, you press it so the opening will open, built-in opening. You finish your sounding, take out, you let go, you lift up your foot, it will close automatically from inside and then you second precaution you close it from the top. So that is how the things are in engine room. Now what happens, We also have got other tanks which are not huge tanks, and you don't want to contaminate them by everyday sounding tape and all. So a lot of those tanks have got the pressure gauges to tell you how much water is inside, how much liquid is inside. Normally freshwater tanks, you can generally read it on a meter, or there may be a glass tube connected. That means instead of having this sounding pipe inside the tank, it is placed outside and connected from the bottom. That means instead of this tank inside, it is placed outside and it is connected, so that inside liquid, outside liquid will be in same level. In that case, I just look at it and I read out, because there is a scale along with it. So I read out, okay, this much water is there. So generally for freshwater tanks, lubricating oil tanks, that is where you will find these gauges. So we call them gauge. Okay. Now here you have got, this is the pipe in engine room, sounding pipe. Now here you will see there is something here on top, that is a normal opening, and here you can see here. Can you see this? What?
Yes, sir.
Yes, sir.
Yes, sir.
That is some sort of a pedal. You press it so that there is an arrangement, internal arrangement, that opens up. It is spring loaded. So when you keep it pressed, it opens the opening here. So then two openings are opened up. The tape is lowered inside, measured, taken out. Then you remove your foot from here. It will close, and then you manually close the top one. That is how the sounding pipe is in engine room. Now, this is another example of sounding pipe on deck. See, there is a cap on top. You open it up and you can lower it down. There is another sounding pipe here. There is another sounding pipe here. So these are the sounding pipes. The purpose is to measure the depth of liquid inside. Okay? Depth. Always remember, sounding means depth of liquid. Now what happens is, how do we take sounding? This is called sounding tape. Okay? It is made up of a steel strip. It's a thin strip which you wind it. Just like if you have seen any sort of measuring tapes, no, long ones and all. Same one, but this is metal. And it is coated with a special paint. Why do we have special paint on it? Because water doesn't stick to metal. Water doesn't stick to shining metal and all. So you will not know what is the. One second, huh? One second. Okay, sorry guys. What happened was, just now I got sort of whiff of something burning, and because my window is open, it was from outside. But then I just wanted to check in kitchen that nothing is burning. Okay, so this tape is coated with a special paint where the water sticks, and that is, then there are other methods which are used by engineers when they check the level of the oil. Then they use water finding paste and all. What happens is, there is a special, it's like toothpaste type of stuff. You put it, then they take it out, then the liquid is there, then they start putting some thinner, a solvent. Then you find the oil reacts with that paste and indicates exact level. So sometimes they have this issue of water getting mixed with fuel oil. Okay, coming back to this, how do we take the sounding? This is the tape. I lower the tape in sounding pipe till it reaches the bottom. Okay. Now this bottom we will be discussing further. Now what happens is, this is, you realize this is the metal one. This bob, plumb bob is metal, and it is pointed so that it can move smoothly in the tank. Now what happens is, I take sounding every day, 2 times a day. Very nice. Even though this is brass, one of the softer metals, brass, and it is hammering against my keel plating, for example. Okay, assume this is double bottom tank, it keel plating. 1 day, 2 days, 1,000 days, 2,000 days. What will happen is, every time this point hits the steel surface, yeah, it will take the damage, but it may be like 70-30, 70% it's taking damage, 30% the steel is getting damaged. And so you will end up in a situation after maybe 10 years that the keel plate metals, means bottom shell plating metals, have thinned down there where you were banging all the time. Then there will be a bigger problem. If it gets hold, the water will come in. If it is too thin, you will have to replace the metal, which is expensive. So instead of that, a simple idea is used. We take a small plate, small steel plate, just something like this, just like you can say this sort of a box type of shape, but a circular. Okay, and we weld that on top of the hull plate, bottom shell plate. We weld on top of bottom shell plate a metal plate, and we make the allowance for the this thing. I know if it is, I use 1 centimeter thick, so my level will be 1 centimeter more than what I measure. Correct? Clear? Is it clear?
Yes,
Yes,
sir.
sir.
Very good.
Yes, sir.
So what happens over the period? This small plate, what we have welded 1 centimeter, will become thinner, 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 and once you realize that is worn out, you just replace the plate. It is much cheaper to replace a small plate of this size than cutting the hole in the hull and replacing the big plate. You understood the purpose of this small plate? Hmm?
Yes, sir.
Yeah, it is sacrificial, and it is called striker plate. It is part and parcel of sounding pipe. The striker plate is there. Okay, all the sounding pipes will have a striker plate at the bottom, always, and the purpose is that is sacrificial. Over the years it will get worn out and it will be replaced, but no damage will be done to bottom shell plating. Now this is one method, right, to measure the depth. Now it happens sometimes that measuring depth may be more cumbersome, because every time the tape you'll have to clean up this tape. So cleaning, it will take a lot of time. If it is oil, water is not a problem, but if it is oil, there's a bigger problem, because every time you will be cleaning it up over. So what happens is, there is another method. Finally, I am looking at this, calculating this volume. One method is, I know the sounding value, I know rest of the surface area, and multiply and I get a volume. Is whatever it is according to the calibration table. There is another method. I know this is 100% volume. If I know the empty space on top, if I can measure empty space, I just need to subtract it from the full volume. to know what is the liquid inside. Is it right?
Yes,
Yes,
sir.
sir.
Yeah. So when we use that type of method, that is generally used with all chemicals, oils, and all, not for water, it is called ullage. This is called ullage. Ullage. Okay. Now, since I am measuring from here, this is the height of ullage. If I was measuring from this, it will be height of ullage. So this ullage is done. Now, earlier days, what we used to do, we used to use the same tape with the openings were bigger, and we used to have one small wooden plank tied up. So wooden plank floats. So when it goes down, it moment it touches the liquid, it will start floating, and I know what is the height. Now what happened? There is a modernization. So there are ultrasonic gauges. They transmit the waves and measure the thing, just like echo sounders and all work, but they work in a little different way, and that is how they call tank scopes and all, where on a sealed cargo tank we know what is the liquid level inside. We have got very modern systems today that is totally electronics, ultrasound waves and all you use, and the thing is transmitted to control room. So sitting in the office you see all the levels in the tanks. So that is based on ullage, not on soundings. Now soundings where we will use normally all ballast tanks, freshwater tank, those are the sounding ones. Because there are also other things, like if you have got say very high grade of lubricating oil, you don't want to contaminate it by every time you open it and put something else drops in. So there is a contamination. To avoid that, you have got a gauges. Fuel oil tanks, they take a ledge by this method only, as it's shown here, this method. And what happens is, they with experience they know exactly how much tape to lower. So some oil will stick here, but they check that mark, subtract it from whatever is here, and that is the ullage, and that is all. So that you don't have problems with the oil. Because see, oil, no matter what happens, if you start taking it out every time, your first thing making it dirty, and second thing it is inflammable. So you have to be more careful of that. Then we have got purposely kept empty spaces, means dry spaces like cofferdam space, void spaces, and bilges, bilge wells. Bilge wells, when you have got cargo in the holds, has to be dry. And you saw the cleaning process where guy was using sponge to mop it up and all to make sure it's absolutely dry. Because a dry place, getting any liquid inside means something is wrong. So we always check it. It is one of those, what you say, boring, thankless job, like every day, morning and evening, and that is strictly cadet nowadays, or generally AB, bosun, they take it, or cadet. Cadets are taught how to take. You take the full round of the ship, all the ballast tanks, whether they're full or empty, you check sounding, you check bilge sounding. Now, what is bilge sounding? Put it, it is supposed to be dry. So you check it, okay, it's dry, good. Like you report it. If there is water, then there is a concern. Then investigation will take place why the water is there, and so on. And then you have got like freshwater tanks, which every day you must know how much fresh water is on board. So there generally you will have a gauge which tells you. So that is sounding pipe. Now, something like sounding pipes, there is something more in the ship's holds. Suppose right now, don't think this is the tank. Think it is a ship's hold, okay, cargo hold. So sometimes you have got these pipes which just travel, but they are sealed. Those are sealed from the bottom, and their purpose is the temperature. You have got a special thermometers which are lowered and kept inside. They're kept inside, and there is a hook and all inside here where it is hooked up. And when you want to check the temperature, you just lift it up and read the thermometer to know the temperature. Those are called temperature pipes. It is not in your this syllabus, but that is one pipe which looks like sounding pipe. Everything top is same. Only once you open it, then you will find there is a hook and there is a chain hooked on, and then that there you can adjust the height where you want temperature. You want top temperature, middle, or bottom. So there can be four temperature pipes in each hole, especially bulk carriers, and that also not all bulk carriers. Some bulk carriers who carry certain cargoes like coal and all, then you will find the temperature pipes are there. But just if you can remember, very good. If you don't remember, it's also fine. We are back to our tank. So you have got sounding pipe ending up on deck, which is closed with a cap. Bottom part, it is left open so that liquid can flow in and out and maintain and show the same level. Under sounding pipe, you have got a striker plate. Striker plate is sacrificial. Idea of striker plate is over the years, when it gets worn out, you replace it without causing any damage to the bottom shell plating. Up to this clear? Yes or no?
Yes, sir.
Everybody is on same level?
Yes, sir.
Okay. How do we take sounding when we take manual sounding? See, today you have got sensors, lot of stuff is there. Like bilge wells have sensors. So if any liquid comes in, it gives you the alarm that there is liquid inside. Because there we are not measuring volume. There we are just measuring presence or absence of liquid. All dry places, you measure presence or absence. That is void spaces, cofferdam tank, cofferdams, and the tanks, various ballast tanks or liquid tanks. There it depends. Like some tanks are meant to be empty. Like there is some tank called overflow tank. Engine for fuel oil, there is overflow tank. That has to be empty. Why? Because you are not supposed to get. But it is in case there is a problem. Instead of oil going overboard and ending up polluting seas and all, it just goes in and lands up in the overflow tank. So those tanks, ballast tanks, are either full or empty. One of the two conditions. Unloaded passage they will be empty, ballast passage they will be full. And sometimes like you have got some extra water taken for some specific purpose. All we need to measure is the volume of the liquid so that you know how much weight is put where. Clear, or is it getting confusing now? So measuring this, you lower the tape, let it touch the bottom, take it out, water will be sticking. That is how you take ballast tank sounding. Then this is sounding. The depth is called sounding, and the empty height, that is allege. Allege is the one which is used basically for fuel oil tanks, diesel oil tanks, and so on, not for ballast. It is not used for ballast. So allege is a system which it subtracts empty volume to give you what is full volume. That is allege. There are modern allege systems with the ultrasonic. You use that. There are sort of a transponders and all. They measure it. They remotely feed the data to your computer system in control room, where sitting in one place you can start, stop pumps, you can do so many things from there, and that is where all the information is displayed. Then, because cargo oil, okay, cargo oil has got same thing. Now we saw the striker plate. Now see, this is the typical case, a side view of a ship. Okay. See how the sounding pipes will be, because there is a full plan of sounding pipes, air pipes on ship. Okay. There is a large number. After peak sounding pipe, starting from main deck all the way to the bottom, is after peak. Fine. Topside tank number 3, which travels up to, this is the bottom of the topside tank. So it travels up to there. Then fuel oil tank number 4. Now it is not going to be the case on new ships, because it's no longer permitted. Only old ships will have it, and newer ships will have built above. This is number 2 is interesting. Now number 2, what you see is, it is the bilges. Okay, bilge well. So the sounding pipe goes to bilge well, and you see how bilge well is the bucket cut into double bottom tank. So here you expect it to be always dry. Always dry. Even on ballast passage, unless you are cleaning the hold, it is supposed to be dry. Then some tanks in engine room, lube oil tanks, some of them are bottom tank, cylinder lube oil, that is bottom. Then some of them are top. Top ones generally have gauges. Bottom tanks, there is sounding. So the sounding pipes are there. They are terminating inside engine room, and that is the one. These ones which terminate in engine room have got this arrangement. This is the grating in engine room. It goes below, but there are two closing arrangements. One is automatically, it's always close. You open it when you need it. Other one is you have to open them manually, the top. Now, what happens? Now we saw the measuring the level of fluid inside. Okay. Now, where are we now? We are only at 9:53. Now, when you're filling up anything in a tank, you're going to get two issues. There is air inside that must be released, otherwise, both the pressures will balance and it will stop filling. So, you have to release that pressure which builds up in a tank. And when you're pumping out liquid, same issue comes up, that there will be vacuum if the box is sealed. So you have to let some air inside, otherwise you will not get the flow towards your pump. Is it clear? This part, the pressure build-up or a vacuum build-up, is it clear?
Yes, sir.
Yes, sir.
Okay. Now, if theoretically if we see that whole thing is sealed up, you can't fill up more than that. Like you must have had this experience while drinking soft drinks from the bottle. You keep on taking some sips and then it stops coming in. Why? Because then you realize there is a vacuum pressure and you can't take it in more. Right? Correct, no? Yeah.
Yes, sir.
Ah. So same thing happens here. So what do we need a system? Now that is one part. Pressure buildup or vacuum. One reason is ballasting, deballasting. Fine. Second one is when ship is rolling and tank is half full, the water level will push, and then some places the local spots will be there, vacuum or overpressure. So it needs to keep on balancing it. Third one, temperature of liquid and the air inside can cause issue. Like suppose I put the ballast that time, the seawater temperature was say 25 degrees, and I got half ballast, rest is air. Air is also 25 degrees, 30 degrees. Now what happens is I go to colder climate, everything drops. That means it contracts. So there will be vacuum. So that vacuum must get filled to the atmospheric pressure, whatever is there. Another one, other way around, cold to hot, and it becomes pressurized. So you have to vent off that extra pressure. So how do we do it? We connect the pipes. We'll come to the location of pipes in the end. Okay, we connect the air pipes. Now what is the purpose of air pipes? Allow tank to breathe. Breathe means when there is a vacuum, it allows air to come in and balance with the atmospheric pressure. When there is extra pressure, it releases the pressure to keep it along with the normal pressure. Now this is all sounding very nice. Somebody will have a doubt, but what about bad weather? Air pipe is supposed to be dealing with air only. Very nice. But in bad weather, the waves are breaking on the deck. So water will go in the tank. Very valid argument. So we have also arrangement in air pipes that water will not go from deck inside. There is a sort of a non-return valve which works only with liquids, not with air. It is an arrangement. My screen is not visible. You can see my screen or
Visible.
no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Visible.
Yes, sir, it is visible.
Sanchit, you were to re-log in or check something. So air pipes also have arrangement to prevent seawater from entering the tank, and it reacts with the liquids only. And the shape is such that rainwater can't go in. It is the question comes when the air pipe gets totally submerged under the big wave. That is where the danger comes. That water will go other way around. So there is a arrangement made. Now somebody else will also ask a question. Hmm? What about the fuel oil tanks where there is inflammable vapor inside? Again, valid argument. Very much valid argument. Normally, what happens? The fuel oil tanks, their issue comes up generally is the inflammable vapor escaping out, which is a small amount because we are not allowed to use any fuels on the ship. Now the new technologies have come and they are allowing CNG and all. Otherwise, we never ever thought about it. Our oils were not that easy to start fire. But all those tanks, wherever there are inflammable liquids inside, have got wire gauze. Wire gauze is like a wire net. It is thinner than the mosquito nets, you see. It's metal and it goes back to the Davis principle. You remember Miner's lamp? You studied sometime in physics. Did you study it or no? Miner's lamp. Huh? Forgotten? Huh?
I don't remember.
Yeah, they will not remember. That's why I'm reminding you. There is something called miner's lamp. What used to happen earlier days when people used to work in coal mines? There were a lot of accidents, fires, people used to die. And what used to happen? The fire, because there is a gas is getting released inside when you're mining. So how do you know what level? So this Davis, one scientist, he made it, he covered it with the wire gauze so that the flame inside could not light up outside gases. Okay. And also remember, this happened earlier days when you did not have batteries and the electric lights available, and you were still mining the coal. So that is how that principle is there, where you cover with a wire gauze. It's also called spark arrestor. That means one side you can have spark, but it will not light up other side. So those are also called spark arresters. Okay. Now, very important thing to remember: air pipes are only for tanks which carry liquids. Okay, air pipes. Air pipes are not ventilators. Ventilators are little different. Okay, so air pipes are not exactly used in cargo compartments. Now there is a specialist system for cargos. Okay, that air pipe system is different, that we will touch it afterward. There is a air piping because it is a tank carrying liquid, but it is more advanced than the normal ones what we see. See, one can say these are ventilators, one can say these are air pipes, because if it is serving coffer dam, it's possible, but they are ventilators. They are not air pipes. Air pipes are only for. Now, don't worry. This one has come up here. It is supposed to be bottom. Okay, this is the website issue. These are air pipes. Then there are heads are different types. Okay, I'll show you something more. These are ventilators, ventilators, ventilators. No, air pipe. Some drawings. This is air pipe. See, the heads will be different, because there is a built-in mechanism to prevent entry of water from outside to inside. So those are the air pipes. Now, the placement of air pipes. Okay. Now this is a longitudinal section. Generally, generally, ships have got little bit trim by stern. That is general thing. Little bit, maybe a meter, 50 centimeters, whatever it is. So, sounding pipes are normally placed aft towards the end of the tank, to in the after direction, means in a stern direction. Like means this is forward, this is aft. Though there is no rule, a small tank air pipe may be put in the middle also. Small tank like engine room tanks, they you will find, but ballast tanks normally you will find it astern. In some rare cases, you may have two sounding pipes, forward and aft. Rare case, not common, but it is possible. Though today you have sounding pipes for emergency measures, but there are also different systems to take the soundings. Like there is something called uh, pneumatic system, where a certain pneumatic pressure is maintained, and there is a pipe, air pipe inside, and it ends up inside and it measures the pressure and converts it into volume. There are advanced systems, but as far as you go, you have to understand what is sounding pipe. Sounding pipe is always placed up. Remember, rare cases it may be placed anywhere else, but normally aft and towards the center line, wherever you get the best depth. Towards center line means double bottom tank, port and starboard. Center line tank will have somewhere in the middle only on center line. Topside tanks will be towards ship side, because that is where the narrow part comes. A topside tank. Wing tanks depending on where, but it will be always aft. After end of the tank will have sounding pipe. Engine down small tanks, they will have variations because then they look at where is convenient position. Air pipes, what we say, you will find this term tank ventilators, and that is why I left it like that. I realized that internet has got term tank ventilators. We call it air pipes, but they are placed one at forward end, one at aft end, and generally the highest part, means wherever you expect it to be higher. Like air pipes are generally the side tanks will be next to ship side, just inside the uh, shear strike. Those are air pipes. Sounding pipe, depending on wherever, like side, anything like port side, starboard side tanks, it will be towards the center line, end of the tank. Center tanks, it will be somewhere in the center line and always after end. Air pipe, one at forward end, one at after end. Normally tanks have got two air pipes. Clear up to this? Yes, no.
Yes,
Yes,
sir.
sir.
Okay. So you understand now sounding pipe and air pipe, correct? No enthusiasm. Hmm? These are all actually one way or the other you are going to see it maybe on ships, but not really going to use it much. These sounding tapes. Soundings you will be taking because it's a traditional thing, and cadets and all generally are reliable on sounding. It is approximately 1.5 hours job in the morning and 1.5 hours job in the evening. If you do all the tank soundings on normal ship, okay, that means freshwater, ballast tanks, bilges, and engineers generally take it around noon because then they can work out the fuel on board, and that is the generally afternoon report. Hmm. So now, what do we do? We continue or stop? What do we do? Continue or stop?
Stop, sir.
I knew that. No, I know. Now we're towards end, so and generally these lectures you all get. Earlier days we had a lot of work like this, sounding. 1.5 घंटा निकल गया दिन का, 3 घंटा निकल गया. So we were sort of busy. Today with automation, you have got everything in front of you on the screen. It can become boring. Means you end up becoming couch potato. It's actually a real danger. You don't have to go on deck. Of course, you will still find, at least today, the captains and all like to take one round. If weather is bad, then nobody goes on deck. Weather is good, one round, and then you have got some guys who do not have work on deck.